To go over these next few dynamic settings, I thought it might be easier to use a little simpler setup here. Simply a plane with some hairs attached to it, and I have it set up very similar to the hair. There are some self-collisions, and we're just viewing the self-collision geometry right now. So let's go ahead and take a look at some of these settings. Go ahead and grab my hair system, and let's come up over here. And let's start by taking a look at the rest length scale. We didn't cover this one in the previous clip. Right now, if the hair collapses, you could see the length stays fairly normal. There's a little bit of stretching, which because there's not a lot of stretch resistance. However, if I were to, let's say, drop my rest length scale to 0.5, it's going to actually come to a rest at about half its current length. And if I, of course, were to bring this to 2, it's going to come to a rest at twice its current length. And you can see that right there. So this, of course, isn't going to be all that effective for hair most of the time, but you can imagine if you are using N-hair for other things such as tentacles and who knows what else you might be using it for, cabling, it can be nice to actually have it come to a rest at a different length. For us, though, 1 is going to work best. We don't really need that additional length. Now, the next setting here, stiffness scale, might seem to you like it's not working. I can go ahead and, oops, let's close that off, maybe drag it all the way down. The hair has no stiffness. And while you will see a change, the change is going to be very, very slight. And let's say I bring the stiffness all the way up. Same thing, the change is going to be extremely slight. It's more stiff than it was, but I mean, it's almost unnoticeable. It's only if you compare play blasts that you'll see it. The reason is that this is actually connected to this bend resistance up here. If I put my bend resistance to 100, you'll notice now with it all the way up, and by the way, left-hand side is the root, right-hand side is the tip. Go ahead and put that there. If I hit play now, you can see it's going to be much stiffer, just as we expected. And now if I go ahead and let's say drop this side, you can see that's going to droop a little bit more. And as I drop over here, that's all going to droop some more as well. So you can set up your own custom stiffness along the length of the hair. Maybe it stays very stiff and then drops off very, very quickly right there. Go ahead and hit play and you'll see that happen right there. Again, this does tie into the bend resistance. So think of it almost as a way to control it. All right, for right now, I'll go ahead and close that off and just keep it at roughly the average here, and we'll put our bend resistance back to 10. Now there is another way to control the stiffness of the hair, and that's through the start curve attract. What this slider will do is act as a percentage to how much it should stick to the original shape of the hair when the animation begins, which is right now this. The hair is sticking straight out. If I go ahead and keep that on and hit play, you can see they will be much stiffer. You'll also notice this is a much faster calculation than calculating stiffness. And I have the same attraction scale down here. I can do this same kind of drop off here that I did before. And you can see that while it won't be as aggressive as the other one, it's overall the same effect. It just tends to be a little bit smoother. And of course I can drop that all down there. Now you will notice with both the stiffness scale and attraction scale, no matter how low we set any of these, we can't really get it to actually bend this first link over here. We can't get that to actually point downwards. To affect that, you need to have much more points in your hair, or many more points in your hair rather, because it takes the first 2 points and keeps those stiff to kind of build the root of the hair. So the more points you have in the hair, the smaller these roots will actually be. And you could, of course, custom build your own hairs if you'd like, and we're going to go over that in the next module. But anyway, that's working with our start curve attract. Go ahead and turn that down. Now, if we head over here, we have this bend model. Now, we have 2 methods, simple or twist tracking. 90% of the time, you want to work with simple. What twist tracking will do is if you actually have curls within your hair, it's actually going to track the twisting of those curls back and forth. If you don't have curly hair, there really is no reason to use this. It's just going to slow you down. You can see if I were to turn it on right now, we're not really going to see virtually any change in our animation. So I'll go ahead and switch this back to simple. Now down over here, we talked about this briefly in the last clip, but just to reiterate, if the mass of the hair is larger, the hair is going to act as if it's thicker, heavier, and therefore collisions will be more visible. Drag, of course, will slow things down if I up my drag pretty high. Whoops, let's rewind there. we'll see that it falls much slower. Now there are 3 different drags. This is kind of a generic drag. It's going to basically slow down its movement in any axes. Tangential drag will slow it down along the length of the hair, while motion drag will be based on the direction it's moving. So you can play around with all of those as you see fit. Damp we've already taken a look at. That's going to slow down the hair by killing off motion over time. And dynamic weight will basically act as a slider to remove the strength of the hair. This will only be visible with collisions with other objects though. Now the last thing I want to look at is here under turbulence. This is not really a dynamic setting, but it can intermix with dynamics. It's going to add random noise movements into the hair. So as I increase this, you'll see that we actually start getting random animated movements in the hair. It's not just flopping, it's now moving back and forth. And you can see I can up my frequency to get more movements in there. I can even up the speed. And it's a nice way to add random motion into hair if a character is standing still, maybe a little bit of wind blowing through their hair and you want to add a little bit more randomness. Maybe as your character is walking, it's not moving as much as you'd like. You want a little bit more motion. You can add some turbulence in there. Or let's say you're even using hair for something that isn't actually hair. Let's say you're actually using it to produce, let's say, tentacles or ropes or something like that, or cabling. And you can go ahead and add this random motion to it, especially if they're kind of slithering tentacles. It can be pretty cool. But anyway, that's a look at majority of our dynamic settings. The only other thing that we can really add to all of this is the fact that you can use your fields, the same ones that work with particles or cloth or anything else. So if I wanted to add, let's say, a Newton field, as long as my hair was selected, go ahead and move my Newton field over here. I can go ahead and crank up the strength on that field, and you can see it's going to be drawn to that field now. So in addition to all those settings, you still have all of these classic fields, which we do cover again in our nParticle Fundamentals course. These fields, of course, are more often used with particles, which is why we cover them there. However, they're very straightforward and easy to use. You just have to select your hair system and apply the effect. All right, so that's all for this clip. In the next clip, let's take a look at how we can actually cache out these motions so that we don't have to always resimulate when we want to watch or play back our results. So I'll see you all there.